Welcome back to the lecture Software Design and Architecture. In the first part of the final module, Design Patterns, we are going to learn what a design pattern is. We are going to explain the relationship between tactics and design patterns. We're going to familiarize with the different categories of design patterns according to Gang of Four. And we are going to learn a few examples in creational design patterns, in structural design patterns, in behavioral design patterns, and finally, we are going to revise some common macro architectures. Recall the following. When we want to design the solution of a software system, we do requirement analysis. Look at the figure. In requirement analysis, we will identify the business functions and the quality of the solution to achieve the functions. Having done so, we need to come out with a solution design. An architecture, as you have learned, contains the components and relationship between the components to deliver the functions, qualities within the constraints. To identify the components, we need to start by looking at the context diagram, which is the first module, the first monolithic module, the system itself, and its interaction with its environment, the system context. So to identify the components, we choose a scenario of how the system could have been used. We identify the system context, i.e. the objects, the actors, the external systems that are interacting with the system. We identify the input-outputs between the sink and sources. And then we can identify the required components of the system by making use of this system context and how the input could be transformed to the output. The process of the input to the output requires suitable algorithms, suitable data structure, as well as suitable tactic. Suitable algorithm and data structure is for achieving the functional requirement. Suitable tactics are for achieving the quality expectation. Tactics are strategy to implement quality attributes. Patterns are solution to these repeating problems. It is an application tactics. Therefore, having identified the tactics, we can proceed to using a suitable design pattern. And all this is based on analysis of the scenario. Then we produce the UML diagrams representing the solution. We identify the interfaces of these components, and we further analyze and refine these components as necessary. By communicating with the stakeholders, which include the business stakeholders as well as the developing stakeholders, the developer stakeholders, we can come up with an architecture that is detailed enough. So, how is design pattern related to architecture? The following figure is useful to help us with this understanding. The x-axis is the scope. of a system design. A system can be designed bottom up, from programming level up to the system structure level. Some components do not require domain knowledge. Some components may require a deep domain knowledge. Domain knowledge refers to knowledge of the business, such as banking, education, medical, etc. Now, let me bring your attention to design patterns. Design patterns define micro-architectural tactics. It is used at programming level, and it does not have much domain knowledge required for its design. This is good news, because this shows that design pattern can be reusable across different domains. Moving to the opposite end is domain-specific software architecture, which defines macro-architectural tactics. Domain-specific software architecture requires specific domain knowledge, such as shipping, banking, education, medical, etc., which makes it less reusable for other domains, except for a specific domain it is designed for. In between the two extremes are architecture styles and architecture patterns. Let us focus back on design patterns. Design patterns are highly reusable because it complies with solid design principles. Solid ensures that a system is easily maintainable and extendable over time by design. Solid principles is an object-oriented design principles. They are made up of the following 5 principles: single responsibility principle, open-close principle, discourse substitution principle, interface segregation principle, dependency inversion principle. Let us revise these principles on how they are related to design patterns. S stands for single responsibility principle. It ensures class designs are cohesive. One class is doing one specific responsibility. O, open-close principle, ensures each class is properly encapsulated. Thus, they are no longer modifiable. However, they can be extended through inheritance. L, discourse substitution principle. This is a principle behind the concept of polymorphism in object-oriented design. It allows a superclass type, a class type, to be replaced by subtype instances. I, interface segregation principle, which encourages the use of many client-specific interfaces instead of one general-purpose interface. Thus, ensures cohesion. And finally, the dependency inversion principle, which recommends the use of abstractions. This is probably why most of the design patterns has many abstract classes and interfaces on top of the concrete classes. By having solid design principles in mind, I hope you'll be able to see why the design patterns are designed in certain manners. They are all traceable back to solid design principles. Solid design principles are especially useful to make sure that the design is highly maintainable and extendable over time by design. We do not want to modify, we don't want to open the class, dissect the class, modify the class. We want to keep the class in the class diagram design as they are without being modified. But to fulfill future requirements, we can subclass these classes without modifying them, and then to use these subclasses for new requirements in the future. This is based on solid. So far, we have learned about the differences between tactics, architecture patterns, and design patterns. Tactics are strategies to achieve quality attributes of a software, such as redundancy, to achieve high reliability of the systems, high availability of the systems. Architecture patterns is focusing on macro architecture. It requires more domain knowledge and is less reusable. It is mostly focusing on system structure rather than the detailed programming design structure. Design patterns, on the other hand, is micro architecture, where it is highly reusable across domain because it does not have much domain knowledge in its design, and it is used at low-level design, at programming level. So let's recap. Patterns are documented reusable solutions to recurring problems in software architecture. This is based on experiences, trends, and errors by previous development in the industry by experts. Their goal is to construct flexible and maintainable object-oriented software. The short-term benefits are to promote reuse of proven solutions. This will prevent similar mistakes from being repeated. When everybody is using the same design pattern, they can converse using the same design vocabulary. This will provide clear procedure for implementation of future software systems. And through reuse and clearer communication, a design phase can be shortened. As for the long-term benefits, which is the benefits gained after the software system has been developed and deployed, is that once the system has been handed over to the stakeholders, a system that is designed based on design patterns follow solid design principles. Thus, the structure is clearer and it's easier for maintenance programmer to understand the design and code. And also, by design, the systems can be extended in a much easier manner through the advantages offered by the design pattern. So what is a design pattern? Let me give you some keywords. Reusable, solution, recurring problems, based on industrial experts' experience. I hope you can form the answer from the keywords that I have given to you. So there are many design patterns. In the following lectures, we'll be looking at the following categories. Despite the number of patterns, they all fall under the three major design pattern categories, which are creational, structural, and behavioral. All these are micro-architectural design patterns. So I will see you. Thank you for having me.